Hey, this is Mr. Ariel. I'm here today with the notes for limiting reagents and percent yield. Now, any reaction that involves two or more reactants, they're going to react based on the mole ratio from the balanced equation. When they combine in a ratio that matches the balanced equation, they're said to be stoichiometric, kind of a tough word to say. Now, if that ratio from the balanced equation does not match the amounts that are reacting, like the amounts we're given in the problem, then one of the reactants is going to run out before the others. And so that one that runs out first is called the limiting reagent, or we'll call it limiting reactant most of the time in class. And the one that's left over, well, that's called the excess reactant. It's a little bit easier to see what we're talking about if we look at an example. So here's an equation for hydrogen and oxygen combined to form water. And we have 4 moles of hydrogen and 4 moles of oxygen. So here are the little hydrogen molecules, and these are the oxygen. Oxygen has a bigger mass, so it's shown as a bigger molecule. And over here, this is H2O. It's 1 oxygen with 2 hydrogens. And we have a lot of oxygens that are left over. So these 2 oxygens right here are left over. They're excess reactant. And the hydrogens back over on the reactant side, these are the limiting reactants. If you count them up on the product side, we have 1, 2, 3, 4, 5, 6, 7, 8, and that matches up to what we had over here. We had 2, 4, 6, and that makes 8 over here. So when the 8 hydrogens were used up from the reactants, and they made the 4 molecules of water, that was the limiting reactant because the hydrogen ran out. And cleaning this up a little bit, I also had 8 oxygens, 1, 2, 3, 4, 5, 6, 7, 8, and you can tell we used up 1, 2, 3, and 4. But those extra 4 are the excess reactant. In other words, the leftovers. So now we're going to look at a second example. It's going to be 6 moles of hydrogen and 2 moles of oxygen, but the rest of it is on the next page, so flip over. Now here's that same equation from the front. We have hydrogen plus oxygen makes water, but we don't have any of the products drawn in. And we're going to figure out what to draw based on stoichiometry, like where we put stuff over one in a time sign and a line. If we have 6 moles of hydrogen, we can just use the mole ratio, that there are 2 moles of hydrogen for every 2 moles of water. And so both of those numbers are right here. And if you do the math on that, those actually cancel themselves out. And so 6 moles of hydrogen will produce 6 moles of water. But on the other hand, if we have 2 moles of oxygen, we can put that over 1 and use the mole ratio between oxygen and water. And that's a 1-to-2 ratio. And so if you do that math, 2 moles of oxygen will produce 4 moles of water. Now the important thing to do here is to compare to see which one produces less. And since oxygen produced less, it's the limiting reactant. And hydrogen is the excess. And so this is a new word here. The theoretical yield from this experiment is 4 moles of water. And we can go ahead and draw those in. I'm going to put in 4 oxygens, just like this. And I'll put the hydrogens that go with each water, just like this. And so those are my water molecules. And if you notice, we used up 1, 2, 3, 4 oxygens, so it's completely gone. But if you count up the hydrogens, I see 1, 2, 3, 4, 5, 6, 7, 8. Well, we had 2, 4, 6, 8, 10, and 12 over here on this side. And so we need to draw in the remaining hydrogens that we have. So again, we had 8 hydrogens used up in the products, but we had 12 to start with. And so I'm going to draw in 2 molecules of H2 that are left over. So again, theoretical yield is just used to describe how much you should be able to make of a substance based on the amounts that are given in the problem. Now there's a practice problem down here, but we're actually just going to jump into the real practice problems because I think it's better to just go ahead and look at how the steps work. So flipping the page, here we're given the balanced equation for photosynthesis right up here, and we want to react 2.28 moles of oxygen with 0.43 moles of glucose. So I'm going to take both of those numbers and write them into my problem, and we set them both up as a problem like a dimensional analysis where we put what we're given over 1. And then we're simply going to work out the stoichiometry to figure out the target, how many moles of carbon dioxide will be formed. And so I can use the mole ratio to do this. Now for oxygen, it's a 6-to-6 ratio, but I need to write the 6 moles of O2 on the bottom, 6 moles of CO2 go on top. And I always recommend canceling out the units like this because if you have the unit that matches up to what you want, that means you're all done with the problem, except for the calculator, of course. Now we can actually skip using a calculator because 6 divided by 6 is just equal to 1. And so this is going to work out to be 2.28 moles of CO2. Now we need to work out the same thing starting with the 0.434 moles of glucose. Now for glucose, you know there's a 1 right here that we never write. And so this is a 1:6 ratio. So I'm going to put 1 mole of glucose, and I'm going to put the 6 for carbon dioxide, that goes on top. So we'll actually need a calculator for this, but let me double check and make sure those units really do cancel out and they leave me with the unit that I really want, moles of carbon dioxide. Now if you plug those numbers in on a calculator, you're going to get 2.60 moles of CO2. And so the question is, how many moles of carbon dioxide will actually be formed? And it's always going to be the one that has the smaller amount produced. Now this is called the theoretical yield, because theoretically, starting with that 2.28 moles of oxygen and the 0.43 moles of glucose, theoretically, we could produce 2.28 moles of carbon dioxide. Now, the question doesn't ask you to do this, but we're going to do it anyway because some of the later you-dos ask you to do this step. So we need to identify the limiting reactant, and that is the one that ran out first, and so that's going to be the oxygen we started with back in the beginning. So the limiting reactant is equal to oxygen, and the excess reactant, the one we had too much of, that's the glucose that if we'd had enough of the other materials, we could have made 2.6 moles of CO2. So that's going to be my glucose over here for excess reactant. Now the last thing we need to do is percent yield, and the formula for that, I haven't talked about it, but it's right above this problem on your page. I just copied it down so we can actually see it here. So I can just plug in, and let me clean all this up a little bit. I got a little bit too much going on here. The problem says if 2 moles of CO2 are actually formed, what is the percent yield? Well, that 2.0 moles, that's the actual yield. I mean, it says it's actually formed. Shouldn't be too hard to understand where we get that word from. So 2.0 moles, and we're going to divide by the theoretical yield, and that's that 2.28 moles. Now with a ratio, units always cancel out, and we'll multiply by 100. And so if you plug those numbers in a calculator, you're going to get 87.72%. And that's the percent yield. There's a lot of reasons why a reaction might not yield 100% of the theoretical yield. Maybe it's not the right temperature to react ideally. I mean, there's a long list of things that can go on. If you want to know more about that, take AP Chemistry with me. But for right now, we're going to move on. So let's jump into the we do problem here. We have a balanced equation, and we have 4.07 grams of nitrogen gas in 2. Well, I know enough by now in chemistry that when I have a number in a problem like this, I'm going to go ahead and put it over 1. And we have 6.01 grams of hydrogen gas, so I'm going to put that one over 1. And we want to know how many grams of ammonia can be produced. So if I have grams of nitrogen, I'm going to start out on that conversion. And I need to go to the periodic table, and I know that nitrogen is 14.01 grams, but there are 2 of them, so that's 28.02 grams per mole. I know I need to put that on the bottom, so it cancels out, and 1 mole of nitrogen goes on the top. I saw lots of y'all working on this while we were learning stoichiometry, and you were tempted to go to the coefficient, which happens to be 1 on this problem, but you only use these coefficients on the next step when you get to the mole ratio. Like right now, we need to focus on these 2, ammonia and nitrogen. And so that mole ratio is 1 mole of N2, and there's 2 moles of NH3. Now, it's really common to get lost on these problems. If I cancel out my units, though, it's kind of like a map of where I've gone. I've got moles of NH3, but I want to get to grams of NH3. So my last step is going to be to do this, to get 1 mole of NH3, and I just need to get grams of NH3 on the top. Well, nitrogen, that's 14.01, plus 3 times hydrogen, that works out to be 17.04 grams. So let me plug that in. And if I do all this math, I'm going to go ahead and do that now. And I recommend working out the numerator first. That would be 138.7056 grams. You don't get to round off anything at first. And then the bottom, that works out to be 28.02 because the rest of it is all 1s. So if we do that math and divide those numbers, we're going to get 4.95 grams of NH3. That's how much we would produce if we started back with those 4.07 grams of nitrogen. Now we're going to work out the 6.01 grams of H2, but I recommend you pause the video and try to work out the steps and see if you get to the right answer. It's kind of important to practice by yourself. But I'll work them out in the video if you just want to watch along with me. So I'm going to use the periodic table, and I know that hydrogen is 1.01 grams. So if we have two of them, that's 2.02. So I'm going to put 2.02 grams, and that's 1 mole of H2. Now I'm going to use the mole ratio, but this time we're looking at the 3 for hydrogen and the 2 for ammonia. So I'll put the 3 moles of H2 on the bottom and 2 moles of NH3 on the top. And the last step is basically the same as it was above, because we're still going to use 1 mole of NH3 is 17.04 grams. So if you multiply that entire numerator, that's 204.8208 grams. We're going to divide that by 6.06. And so that works out to be 33.80 grams of NH3. So the least amount produced is the 4.95 grams. And so that means this is the theoretical yield. And my limiting reactant, I'm going to go with LR on that. That's those 4.07 grams of nitrogen gas. And the excess reactant, that's the one we had way too much of. We would have produced 33.8 grams of ammonia if we hadn't run out of our 4.07 grams with that limiting reactant, nitrogen. So the excess reactant is my hydrogen gas. Now the last part of the question wants to know, what is the percent yield? And so I'm going to do that right over here, the percent yield. I've got the formula way up above in the previous problem. So that's the actual yield, and it looks like I colored over some of that. Here we go. Here's the actual yield, is 4.1 grams. So I'm going to put that in. And the theoretical yield is 4.95 grams. Don't forget to multiply by 100 to finish this out. But when you plug those numbers in a calculator, you're going to get 82.83%. And that's the end of this problem. They might seem complicated and they might seem like they take a little while to do at first, but once you get started on them, they kind of carry themselves through pretty quickly. Now there is one more we do problem to do, so go ahead and flip the page. And for this one, we have 42.93 grams of HCl and 27.5 grams of aluminum, and we want to know how many grams of hydrogen gas we can produce. So I'm going to set you up with the first step on this, but then I'm going to recommend that you go ahead and pause the video and see if you can work out the rest of the steps by yourself. So we're going to put 42.93 grams of HCl over 1, and we're going to put 27.5 grams of aluminum over 1. So go ahead and set your paper up just like this, and we've got to get to grams of hydrogen gas, and this is just stoichiometry that we've done. So I want you to work out up to the point, let me show you in the previous problem, I want you to work it to this point right here, where you know which one is the limiting reactant and what the theoretical yield is. Because the percent yield that happens over here, that's pretty easy to do, as long as you have the numbers correct from the previous step. So go ahead and pause the video and work it out, and then you can fast forward through me doing it to check your answer. Alright, so right now I need grams of HCl on the bottom for 1 mole of HCl. And I know that hydrogen is 1.01 and Cl, that's 35.45. And so that works out to be 36.46 grams. From grams, I need to get from moles of HCl, I need to get to moles of H2. So that is a 6:3 ratio, but the 6 goes with the HCl. And then the 3 goes with the H2. And then over here, 1 mole of H2 is going to be 2.02 grams of H2. Check those units canceling themselves out, and that all works out. So that's 260.1558 grams of H2 over 218.76, and that works out to be 1.19 grams of H2. Now for the aluminum, we can go straight to the periodic table, and that's 26.98 grams for every 1 mole of aluminum. And now we need the mole ratio of aluminum, that's 2, to hydrogen is 3. So I'll put the 2 moles of aluminum down here, and I'm going to go with the 3 moles of H2 in the numerator. And then the last step looks just like it does in the problem right above it, because it's the same exact thing. All right, and if we work out that numerator, that's going to be 166.65 grams of H2, and that'll be over 53.96. So if we do that math, that works out to be 3.09 grams. This is the smallest one, and so that's the theoretical yield. And again, if you're wondering why that's the theoretical yield, when we started back over here with these two reactants, this one, the 42.93, is only enough to produce this much hydrogen. The 27.5 grams of aluminum, well, we could produce 3.09 grams of H2. I should really put that on there. We could produce that much, but we ran out of the other ingredients, and that was the HCl. So HCl is the limiting reactant, and aluminum, that's the excess reactant. Now, the question really wants to know, what is the percent yield? And that's always the actual yield. The problem says that's 1.01 grams is actually formed. And so we're going to divide that by the theoretical yield, 1.19 grams, and we'll multiply that by 100. And so if you plug those numbers in a calculator, it's not real hard. That's going to be 84.87%. Now that's it for all of the I do and the we do. I hope this video was helpful to you today. And as always, thanks for watching.